or I want to get rid of outliers, or I want to... What do you mean?
Something
outside. What do you mean? Something?
Outside the bell.
Something. Ooh. Uh-huh. Something outside the bell. I like that. Thank you, Lloyd. Which means, of course, that there is a bell.
Yep.
So if we've got a bell with an average, put X bar on the bell. What does outside the bell mean? How far outside?
To the where the bell hits the bottom line.
Well, you know what? Believe it or not, we haven't studied this specifically. It never does, believe it or not. This is one of those quirky mathematical things we'll get into as the course goes on. Technically, it goes on forever. So we can't ever pinch it down. So give me a how far out?
The bottom of the bell.
There's no bottom.
Okay. 95%.
Oh, okay. Now we have a quantifier. So you're saying, and I like this. There's two or three different ways we can think about that. We could say if you put 95th percentile, anything above the 95th percentile might be unusual. That's one way of looking at it, right? So if Max is in the 98th percentile for his head girth, we still have to cut his hair, right?
Yep.
If Max is in the 5th percentile for his weight, if this is 5% down here, if this is 5%, you see how I'm putting 5% in a couple different places and then analyzing? Then maybe it's time to talk about what he's eating and maybe he's not getting the nourishment he needs. Or maybe, I don't think you're thinking either of those when you went with 95%. I think you meant centering the 95%.
Right.
Which goes back to our discussion about what to trim off. Yeah, good. I like this. So what would that put in the tails then? If we still want a 95% in the middle, what would that put here? Good, you guys are awesome. 2.5% here, 2.5% here. Good, that's one way of metric and an outlier. Where did your data fall? Did it fall in those regions? If it fell in any one of those regions, then maybe it's unusual. Good.
Is there any sort of consistent correlation with where the bell turns back, where it inflects?
It is. It's a function of the function, believe it or not. If you analyze, don't remember this if you don't want to, but the function for that curve is actually this. And you can mathematically analyze the inflection point on that curve, right there. Don't worry about that.
Is it always at the same percentage?
Yes. For the standard normal curve, yes. And for a general normal curve, we can pull it into a standard and always deal with it the same place. So in other words, there's always a number, the same number, that corresponds to that. This would be 1.645.
It doesn't correlate with a 68 or 95, though.
It does. It does. This one corresponds to not those, actually, because it's within standard.
68 seems... I know it's not arbitrary, but it feels like it is.
Good. Did you hear what Tom just said about that 68? 68, 95, 99, right? Remember those from the empirical rule? The 68 is an arbitrary number because we have chosen to talk about one standard deviation. That's why by us using integral values for 1, 2, and 3, those just happen to be the percentages that are tied to those integral values. If we use integral values of the areas, we get fractional, weird, irrational values on the axes. So this one here is 1.64545 something. It's a weird number that has a nice percentage. See what I'm getting at? Yeah, no, very good. Very good. And more on that in the back part of the course. More on that. I want to leave it go for right now because that's such a micro view. I like going in this course macro to micro, because it seems to fit the bill better by getting the big terms down to the micro ones. Thank you, Tom, for that. I promise we'll get back to that, I promise. What else? Outliers. Lloyd, thank you for that. Something outside the bell. I like that very much. Oh. What else? Outliers. Be as general or as specific as you want to. When you think of an outlier, what are you thinking of? Please.
Distance from the mean.
Good. Distance from the mean. I like this one, Sandra, because mean as a because you have talked about distance from the mean without referring to a bell curve. Because we should be able to identify outliers without having necessarily a bell curve. We should be able to identify outliers at any point, I think. I would hope so anyway. Good. What else? This is great. Any other kind of words that pop into your mind?
2 standard deviations.
Oh, good. Which ties back to this, right? Good. Good. That. Thank you. 2 standard deviations. Actually, believe it or not, you guys actually have nailed the most common statistical flag for outliers. You know what? Let's just start a list over here. Metrics for outliers. I love the word metric, being able to measure something. How do you measure